Okay, so just to sum all this up, there's 6 ratios. The 6 trigonometric functions are based off the sides of a right triangle. That's all they are defined as ratios of different sides. That's all it is. Okay. So when they ask you to find the sine of some angle, you're actually finding the opposite over the hypotenuse of some triangle formed by that particular theta. Okay. That's technically what it is. Like, we don't usually talk about that detail. We just kind of plug in the calculator, get our value, who cares? But technically that's what's happening. Okay. But those values would be found with your unit circle or your calculator. Okay. But that's how they're created. That's how they're defined. That's where they come from. Okay. So the original 3 are right here: sine, cosine, tangent. And then the other 3 are just reciprocals of the original. Okay. All right. Let me write down some identities and we'll get to some examples. There's the definitions. Yeah, the first one, as we said earlier, cosecant of some angle is a reciprocal of sine. So that means that it's equal to 1 over sine. Number 2, secant is a reciprocal of cosine. So that's going to be 1 over cosine. 3, cotangent will equal 1 over tangent. Okay. So those are the reciprocal types. Now the quotient identities. Number 1, tangent theta is technically sine theta over cosine theta. So you can rewrite it as a ratio of those two. Number 2, cotangent, of course, would be the reciprocal. So that would be cosine over sine. And I'll wait a bit before I turn the page. So give me one more set of identities, and we'll start examples. All right, you guys cool on this page? No rush. Okay, so one more set of identities. These are the Pythagorean identities, I think one of the important ones. So there's 9 of them, but they all come from a single equation. So technically you can create them all yourself if you remember one of them. And that's this one right here. Sine squared theta plus cosine squared theta is equal to 1. So this is the identity. Right? Now, the other 8 just come from doing algebra. That's it. So for example, if I subtract cosine on both sides, I create the second one. Do you see? Basically solve for sine and you have another equation. Solve for cosine, subtract sine on both sides of the original, and you get this one. So you can always substitute a cosine squared for a 1 minus sine squared, or you can substitute a sine squared for 1 minus cosine. So you're going to be doing this for a very long time, depending on your major, but for sure a lot in this class. This will keep popping up. And engineering and programmers and physics, this you'll probably memorize these after a while. It's going to keep coming up. Anyway, so those are the first 3. Now, if you were to divide things, you get another set. If you divide by, let's say we divide the original by cosine, right? This term by cosine, this term by cosine, this by cosine. Do you see that this would become sine over cosine, right? Which is a tangent. This would become a 1. And this would become 1 over cosine, which is secant. I skipped the steps just because I don't want to get the notes all messy, but do you see what I'm talking about? I'll write it up here if you don't. So imagine dividing everything by cosine, the original. You see how we get this, right? This is secant. So as we wrote in the last page as a reciprocal identity. Cosine divided by cosine is a 1. Well, there it is. And we wrote that sine over cosine is tangent. So if they're both squared, of course, this will be tangent squared. So technically you can derive these yourself. Or you can write them down on your formula sheet. That's totally fine with me too. But you need to see where they came from at least. So now subtract the 1. Get another one. Subtract the tangent and you get the last one for this set. Okay, so you see how we're deriving these ourselves. Okay, then do this similar thing here. Divide everything by sine, and you'll get another set. So get to the original, divided by sine, and you're going to get 1 plus cotan equal to cosecant. And then just move things around, and you have the total of 9, all 9 formulas. Subtract the cotan. Subtract the 1, and then we got all 9. So here we divided the original by sine squared. Here we divide by cosine. And that's how we built them. Anyway, any questions on that? I mean, it helps to be able to derive them when it comes to identities. It'll help you understand them. Eventually you're gonna have to, but if you don't see it now, it's not a huge deal. But make sure you have them handy because you're gonna need them. Any questions so far on the formulas and identities or definitions? Yeah, man. I really thought June was gonna be chill, but it looks like it's gonna be horrible. I don't think I'll have a break till late July. I don't know about you guys, but I hope you guys have a summer at some point. I don't think I'm gonna have a nice summer. I was planning all these ideas. Oh, I'm gonna build a new gaming PC, finally play some games, go to the river. I don't think any of that's happening. It's not gonna happen. I was thinking of going to the beach too, but doubt it. I think I was dreaming that I had free time. We'll see. We'll see. Okay, example 1. So those are all the identities we're going to need. I think for most of chapter 6, I'll probably write them again at some point because they keep coming up. But example 1, let's see here. They're going to give us a triangle, a right triangle, and they want us to build or find all the 6 trig functions. So that's going to pop up in your homework, and I'll show you in just a moment. So let me open that up while you finish that. Finish writing those down if you are. That's weird. Oh, I see. That's the wrong link. All right, 6.2. The 6.2 is not going to be too bad. Promise. Let me show you the homework. If you have an idea what we're doing. This load properly. Okay, so the first few questions again are just like before, are more conceptual problems. Like, definitions of the sine cosine. That's what I just gave you. Again, more definition type stuff and ideas. Here's what we're going to do next. Given a right triangle, can you build or can you find all 6 trig functions? Notice how we don't have the hypotenuse, right? So we have to use Pythagorean theorem. So all that, I'm sure you're very comfortable with that, but we'll talk about it again just in case. to find the hypotenuse, and then we just build the sine, cosine, tangent based on those definitions. Okay, so that'll be our first example. Let's see here. Here's the same type of thing, but they have you do it on two separate triangles to show you that there's this idea of similar triangles that are proportional to each other. Let's see here. Same type of thing. So let's go ahead and do that first type of example. Okay, let's see if there's any weird questions I don't like in here. Let me see real quick. Because those are easy. This one just looks weird. Maybe one of these word problems I'll get rid of. There's maybe too many. Anyway, we'll talk about that later. Let's get to the example. Some having issues with this thing. Okay. One second. Okay. Can't see my exit full screen. That's weird. I guess I'm just ignoring it. Okay. So example one. Find the value of the 6 trig functions. Okay. So they give us, let's see here, a right triangle. They only give us 2 sides. So we can't we can't do any of these because sine theta requires a hypotenuse, right? The originals. Should I make more space? Okay. Sorry about that. Cosine adjacent or hypotenuse. It's going to be something. Tangent will be opposite over adjacent. You don't have space. Be there. Now, when you do a Pythagorean theorem, it doesn't matter. if you call this A or this B, they're just the legs of the triangle. And Pythagorean says when you add the sum of the legs squared, it will be equal to the hypotenuse squared. Doesn't matter which one is which. So again, this only works for right triangles. So eventually we won't have right triangles. Okay. So again, doesn't matter which one's A. I'm just going to plug in the 9 in there. Plug in the B. Solve for C. Okay. I think that's going to be one of the pretty ones. If you square root this nonsense, you have to square root both sides, right? What is C going to be? To the side, it's supposed to be a 40. 40. I put 41 by accident. It's going to be 41. This part is 41. So it's one of those nice, pretty triangles. It gives you whole numbers. And it's not going to be common, but let's start with one of those. Okay. So C is equal to 41. I don't have my calculator. I need to grab that in a second. Opposite. So remember, whenever we say opposite, we mean opposite to the angle in question, right? If theta was up here, opposite would be down here. You see what I mean? So opposite depends on where you wrote the theta or where the theta is given. So be careful with that. So currently, opposite to this particular angle is 40, right? So 40. Hypotenuse we found to be 41. Adjacent, meaning right next to the angle in question, theta. Cosine of theta is adjacent 9 over hypotenuse. The only one that will never change will be your hypotenuse. That's always going to be a specific spot, no matter where theta is, right? Opposite and adjacent, 40 and 9. So there's 3 of them. Once you get those 3, all you have to do is take reciprocals and you'll get the other 3, right? Because we said the reciprocal of sine is cosecant. So just flip it over. So cosecant is equal to hypotenuse over opposite, which is 41 over 40. Reciprocal of cosine is secant, which is hypotenuse over adjacent. That'll be 41 over 9. And then cotangent would be 9 over 40. So these are my answers. I should have wrote that prettier. Oh well. Okay. Any questions on this idea? You see how we're just using the definition. You may have to build the triangle yourself, or they might give it to you. Most likely, you might have to find the missing side. Nothing crazy. There we go. Stupid thing. Okay. So the other type of question is, if they give you one of the functions, can you build the triangle and then find the rest? Okay, so it'll be similar to this, but then you understand or have the definitions handy. All right, you guys cool on example one? All right, let's do example two. So let me know. So given, let's say they give us secant. Go to 12. Can you find sine, cosine, tangent? So secant is defined as what? That we need the definition. Now we said it's the reciprocal of cosine. So if you remember cosine, just flip it over, right? So this will be yeah. Okay, so we have a whole number, but we can always write whole numbers as 12 over 1, right? Or that number over 1. Because it's still 12 if you divide by 1. So this is my ratio. So basically you force a ratio and build your triangle. So hypotenuse right there. Adjacent, well, that depends on where I put the angle. So 1. You need to solve for this side here. So we have a squared plus b squared equal to c squared. We have, let's say, let's say I want to find the a, and I have the b. Plug in your c, solve for a. So that'll be 144 minus 1. So a is equal to 1, the square root of 143. So that doesn't show all the algebra there. Let me know if that's okay or not okay. So once you build the triangle, just fill in the blanks, right? Sine theta will be opposite over hypotenuse. Cosine will be adjacent over hypotenuse, which we kind of already had. Tangent of theta will be square root of 143 over 1. Those are 3 answers. Any questions on any of these steps? So your first few questions, maybe almost half of them. The first, I guess, first half will be find the ratios. Well, first will be the definitions and concepts, and then find the ratios given a triangle or given one trig function, and you find the rest. That's it. Number 9 on your homework is just, can you punch this into a calculator? Now, the only thing you need to worry about is your calculator in radians or degrees? So let me go get my calculator. 1 second. Okay. Alrighty. What are we doing? Yes, calculator. I'll show you with both. I mean, it's almost the same. So you look at question 9, it says sine of some degree. So if I click or press, where's the functions? Sine, mine's 15.7. So the calculator doesn't tell you if you're in degrees or not. Well, not with a symbol, but up here it says degrees mode. So we know that we're good if the question in the homework says there's a degree symbol, then it better be degree up here, right? Now, if it says, if it has like pi over 2 or pi over 4, then obviously that is a radian. If it doesn't have a pi, then they better tell you. Otherwise, that's an easy way to think about this. If you don't have a degree symbol, it's safe to assume that it's a radian. Okay. If you have a degree symbol, obviously degrees. So if, let's say they said, I don't know, let's say they wanted cosine of pi over 4. So currently I'm still in degree mode. So whatever I get, whatever, when the calculator reduces this thing inside, it's going to assume I'm into degrees. So you're going to have to go into mode and change to rad. Let's press enter on it. Then you'll be good. And it actually gives me the exact answer on your unit circle. It's kind of cool. Same thing for the graphing type. You just go to mode. Oh, man, this thing's a little bright. 1 second. And then you go to radian or degree. Okay, just right there. You just toggle and press enter. Just make sure before you do anything, you know what mode you're in, because I hate when people, well, I hate when that happens to you guys. You think you're right and you're done, and then it marks it wrong. You're like, why? What the heck happened? It's something simple like that. Especially if you're running out of tries. I don't want you to waste one. Okay. Anyway, so if you look at number 9, you go ahead and share the screen again. You see how all they want you to do is plug it in a machine. Nothing crazy. Super easy. Just round correctly and make sure you know how to switch degrees. Switch to radians, make sure you know how to round correctly, and that's it. Okay. Over here, similar stuff we already did. Given cosine, can you find the other functions? So build your right triangle, find the missing sides. So that's a lot of the questions are going to be just about that. When you get to 12, they have some basic identities. So this is going to be more about, do you know them or can you pull them up, make sure you have all of the formulas I gave you. So we should know that cotan and tangent are ratios, right? So if you look at the ratio property I gave you on page 1 of the notes, tangent is sine over cosine, right? Cotan is obviously cosine over sine. So if you rewrite it, you're going to see that this is going to cancel out and give you a 1. So all I want you to do is fill in the blank. So they're kind of testing it. Do you know the identities? So just look up the page and you put in the right thing. Okay, I'm not going to force you to memorize them, even though my professors made me memorize 50 of them before each test, but I'm not going to do that to you. Just have them ready and know how to use them. Okay. And depending on your major, eventually you're going to memorize them anyway. Okay. But yeah, as you can see, they're all just identities, basic algebra. So I'll let you guys work on these. And if you have questions, we can do some together later. Trying to find something that we can do together, but I think there is. There was something I saw earlier. What is it? I say we work on these here. Just notice how we're missing 2 sides now, but they give us an angle. So we kind of have to figure out the other 2 sides based on the angle. Okay. That shouldn't be too bad. So let's do that and then some word problems. Okay, let's see here. This seems nice. This one seems super weird. I don't like it. Get rid of that one. To say that. Okay. Let's do number 22. I'll leave the other one to you. Let me switch over. Problem 22. Find the exact values of x and y. So in the homework, they gave us this guy right here. I'll put it over here, I guess. This symbol right here, I'm sure you know already that this means it's a right triangle, a little box. They give us some theta. Actually, they give us 60 degrees here for theta. So I'm just going to write the 60. That's our angle. X is the horizontal. Y is vertical. Opposite and adjacent, right? So we can use the definitions of the 6 trig functions to solve the missing pieces. We can say, oh, let's see here. Yeah, let's use sine to solve for y. Because we know that sine of theta is equal to opposite over hypotenuse. So that means that sine of 60 degrees is equal to y over 14. So just solve for y, that's it. So multiply both sides by 14. That'll get you to here. Y is equal to 14 sine of 60. So that's when you have to use your calculator or your unit circle. Okay. Okay, so where is the unit circle? 1 second. Sure, you have it too, so I want to open it up. That'd be cool. Okay, so sine of 60, like what does that mean? Well, you build the ratios and you look at the y value. So sine of 60 degrees is going to be the y value right here. Okay. Okay, so that would mean that we will replace sine 60 with square root 3 over 2. Okay, so you're gonna have 14 times square root 3 over 2. So 14 times square root 3 over 2. That would be 7 root 3. Right? I skipped some algebra here. You guys see how I got to here? Because I skipped a little bit there and here. Let me know if you missed something or if you don't see it. No big deal. Okay. Well, let's say you find the y. If you're good on that, let's do the x. Just remember that it's a 7 because 14 divided by 2, right? Becomes a 7. That's the part I didn't show. So now x. Well, we'll use cosine, right? Cosine of 60 is equal to x, the adjacent side, over 14. So solve for x again, and multiply both sides by 14. That gets us to here. So x is equal to 14 cosine of 60, which will be 14 times 1/2 based on your circle. That is the ugliest 14 ever. One half times 14 obviously is 7. So there is my 2 missing sides. Is there any questions on any of these steps here? Does it make sense? Okay, so that you'll have a couple of these types of questions, which will help you do the word problems, because basically the word problem is this exact same thing we just did, except you kind of have to draw the scenario. Only difference. Now wait a bit and we'll start a word problem. Then we'll take a break. Yeah, sure. You have no questions on how we found X or Y, correct? It's okay. Don't be afraid to ask me anything. All right, so as you can see, 22 and 23 are similar, except you'll be finding different sides. So the trick to this would be choosing the correct trig functions to help you out. You notice how I chose sine and cosine, right? Like you need to decide, okay, which one should I use? You want to use one that does not have two unknowns. So let's say on this guy, just to set you up, I want to find r. Well, I should probably use sine, because if I use cosine, notice how the adjacent is missing and the hypotenuse is missing. So cosine can't do anything for me. So I would do sine first, because sine is opposite over hypotenuse, which means I have one unknown and I can solve for it. Once I solve for that guy, well, I could do Pythagorean theorem, or I can then use cosine. So it doesn't matter. But you need to choose the correct functions depending on what's happening. Okay. Ready? Now let's do this one. I'll let you guys do the other two. 26, and then we'll take a break. So a biologist wants to know, I'm going to copy this into the chat so you don't have to write it all down. And so you have it when I switch over. Let's know the width W of a river. To properly set instruments for an experiment from point A to, let's see here. From point A, the biologist walks downstream 100 feet and sights the point C to point C. Okay, all right. See the figure. From this sighting, it is determined that theta is 48 degrees. How wide is the river? All right. So what's the beauty of trigonometry? You can find all kinds of measurements without actually going out there and measuring the whole river, right? If you have a couple of distances, you can figure out all kinds of stuff, which is actually what a lot of surveyors do. You ever seen them on the street with a little tool trying to figure out stuff? All they need is certain types of measurements, and they can find distances, heights, all kinds of stuff. And when you get further into the class, you'll see you can find certain angles or certain heights without actually being at that location, which is pretty handy if you can't get close to that building, right? Let's see here. Oops, my professor would always give us military examples. He'd say, yeah, if you're being shot at, and you can't go measure the distance of A to B, then you can use this function to figure out how high they are in case you want to use artillery to shell them. But I am not a military person, but I always thought they were pretty cool examples. But we'll talk about them when we get there. Where is the button here? Okay. So you guys cool on example 3. I'm gonna go ahead and start the river problem. All right. Okay. So let's just draw their picture, right? I'm not an artist. I was very bad at arts and crafts in elementary school, and obviously handwriting, but you know, oh well. This is how it goes. So we have some river. We're over here at point A. Pretend it's right on the edge, but who cares? And this distance over here is 100 feet. All right, point C is what they want to know. The distance across the river is the width. They want to know how far this is here. Now notice how we don't have hypotenuse, which makes sense because if you could measure this distance, well, why wouldn't you measure this distance, right? But if you have the angle, so you can figure this angle with some surveyor kind of tools, then you can calculate the distance without actually throwing a rope across with some tape measure. So theta, they said was 48, right? Degrees. So I need you to think about this. What trig function would you use to figure out this missing side? Because that's something you need to decide on your own on exams and homeworks. What do you guys think? It might help to write down what sides we have. What side do we have? Is this opposite or adjacent? Yeah, we have adjacent, right? So opposite currently is a mystery. I don't know. Adjacent is 100 feet. Right? Hypotenuse is unknown. What I want to find is opposite, right? I don't really care about hypotenuse. We want to know the width of the river. So we don't need to do any extra work. All we need is to find opposite. So if you have an adjacent side and you're looking for opposite, what trig function would you use out of the 6? Should I think about it? Well, let's think about that. If we use sine, we would need the opposite. We would need the hypotenuse because sine is equal to what? Opposite over hypotenuse, and we're missing both. So we can't use sine because there's 2 unknowns. Cosine could work. Well, cosine requires, again, hypotenuse. So cosine could help you find the hypotenuse, but that's not what we want, right? Because cosine is equal to adjacent over hypotenuse, which we have adjacent. So we technically could solve for hypotenuse. But then we're not going to do extra work if they didn't ask us to, right? Screw that. They said only the opposite. So tangent would be equal to adjacent over opposite. We have adjacent, so that means we can solve for opposite. So we want to do tangent. Do you see the logic or how you decide? Okay, that's what I need you to see. That's the hard part. The actual algebras or whatever. Tangent theta is equal to opposite over adjacent, right? TOA. So tangent of 48 is equal to 100 feet. Actually, my bad. Opposite over 100. Feet. So solve for opposite. or you can call it X if you want, or Y, whatever, who cares. Multiply both sides by 100. This time I'll go ahead and show the step here. So that means that the opposite side is equal to 100 tangent 48 degrees. Approximately, what is that distance? And don't forget that we are in feet. I should be right in feet. Hundred and 20. Is it 48 or 40? Yeah, it's 48. Am I in amount of degrees anymore? Shoot. There we go. See how you gotta be careful and double check. Degrees is gonna be 111.1 feet. Any questions on the thought process or the setup or solutions? Okay, well, it's 12:40. Let's take a break till about, let's say, 1 o'clock, and then we will. Let's see here. We'll finish 6, 3, 4, and 5 pretty quickly. Okay. So we did the long one. The rest are not too bad. Let's take a break and try to wake up a little bit, and we'll hit 6, 3. Then we'll do some homework. So computing the values of the trig functions of acute angles. So the first few examples is just using sine of 60, cosine of 60, sine of values that are on the circle. Okay, so just have your PDF open, and then you can follow along. Nothing crazy. Let me open the homework though, make sure it matches up. I'm always paranoid that I'm missing something. 6.3, here we go. Actually, it should be any angle. Let's go ahead and look at the homework real quick, so we have an idea what we're going to see. Again, starts off with some conceptual stuff from the book. Here it gives us a point, and says find the 6 trig functions from this value 3, 1. Okay, doesn't seem too bad. We will have to build a triangle based on this idea. Okay. So very similar to what we've done before, just a little more complicated. And some new ideas about reference. Okay. All right, cool. Let's go straight to the examples this time. We have plenty of notes already. So example 1 for 6.3, let's look at problem 5. It says find the 6 trig function. So if you're given a point and not the triangle, you can easily build one, right? Because we have the distance from the origin. Give me some point like that. And they say that this point is 3, 1. Okay. So that would mean that the distance on the x is going to be 3, and the height is technically 1, right? Does that make sense? So then we technically do have a triangle if you're given a point like this. And we know that a squared plus b squared is equal to c squared, which means that 3 squared plus 1 squared is equal to c squared. That would be 10. So c is equal to square root 10. Okay. So it says find the 6 trig functions. Once you have your triangle, that is no big deal. That's the same thing we did earlier. So sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent opposite over adjacent. And then the other 3 are just reciprocals, right? Who cares? Reciprocal of sine would be cosecant. So flip over the square root 10. Reciprocal of cosine is secant. So flip over the cosine. Cotangent is the reciprocal of tan. So flip over the 3. 3 over 1 is 3. So not too bad, right? Any questions on the work here? Does it make sense? I'll let you do part B on your own. That's number 5, part A. Okay. Let's look at question 7. You guys cool on example? All right. So example 7 tells us determine what quadrant theta is in. Remember, I gave it in the first at the beginning of 6.1, I told you the quadrants, right? 1, 2, 3, 4. And I told you if you're quadrant 1, everything is positive. Quadrant 2, we said x is negative. Keep in mind the hypotenuse will always be positive. Only the x and y values that are part of the sine and cosine are going to change. So x corresponds to cosine. And x is negative in quadrant 2 and 3, right? If you notice this right here, it's saying that cosine is less than 0. So cosine is negative. That's what this statement is saying right here. So that means it has to be either 2 or 3. Then it says that sine is also negative. Okay, well, that means the x and the y are both negative. So it has to be quadrant 3. That's the only place that both x and y are negative. So here they're just going to test you, like if I tell you that sine or tangent or whatever is negative, can you figure out what location theta is going to be? Okay. So look at the little chart I gave you with the quadrants. Or just remember where x and y are negative. Sine will be corresponding to y, cosine will be corresponding to x. Okay, tangent is a ratio of y over x. Right, all of that is technically part of the definition. Also the circle, so look at your circle. Where is that stupid circle? So, here it is. So again, sine is all the y values. So if they tell you that sine and cosine are negative, right, that means both of these have to be negative, which only happens in quadrant 3. If they're both positive, well, it has to be quadrant 1. And you can see x and y positive. Tangent is a ratio of y divided by x, okay? So if tangent is negative, then it has to be either 3 or 4, because when you divide positive by negative, right, it has to be negative. So you can kind of figure it out, like, oh, okay, I can see what quadrant they're talking about. If tangent is positive, then it has to be 1 or 3, because positive divided by positive is positive, negative by negative is positive. So it could be either one, I don't know. So we need more information, but that's how I want you to look at it. Y is sine, x is cosine, tangent is a ratio of y over x. And then of course, secant, cotangent are just reciprocals, so who cares? But anyway, keep all that in mind as you're doing these, right? So over here, check it out, number 8. Cosine is positive, so that means it could be quadrant 1 or quadrant 4, right? If you look at your circle one more time, 1, all x's are positive, right? Because cosine is the x. Quadrant 4, the final quadrant, x's are still positive, so it can be either one, right? Okay, what other information did they give us? They said that tangent is negative. Okay, well, that means that one or the other has to be negative, but it can be x because x is positive. That's what this hint is right here. So what quadrant would this be? They're not asking, but can you tell? If x is positive and tangent is negative, which quadrant is theta? So if cosine is positive, it has to be one of these two, right? But if tangent is negative, which one does it rule out? Like, where does it force me to be? So you see how you reason your way through this? It has to be quadrant 4, right? It's the only way y divided by x is negative. And only place that x is also positive. No choice, it has to be here. Quadrant 4. Which will be handy because when you solve for the triangle, right? We know that the x is 12 and it is positive because it's right there, right? Hypotenuse will never be negative, so it's just there. The y is going to have to be negative. So when you do the Pythagorean theorem and you square root both sides, technically each time you do Pythagorean theorem, you should be doing plus or minus square root, right? We don't always do it because it doesn't matter, but this is when it starts to matter. So if I solve for y, right, or this missing side, right, we'd say we have a squared plus E squared. I plug in 12. Plug in 13. Eventually I'm going to get to this. B. It's 13 squared. Is that 169? 60. Minus 144. What's 144? Okay. Which is 25, right? So screw with both sides, right? This is the part I'm talking about. B is technically supposed to be equal to plus or minus 5. We just haven't been doing that. So you choose the plus or the minus depending where theta is. So since we are in quadrant 4, we said, right? Then we know that the y value has to be negative. We know that sine is negative. See that's why these values right here have a minus, because we chose minus 5. So now it matters like what quadrant we're talking about. Does that make sense? So anytime you do square root of both sides, you have to do plus or minus every time. I've just been choosing to only write positive because we were dealing with quadrant 1 and it didn't matter. Now it does. Okay. Any questions on problem 8 here? Okay. So it's almost the exact same thing we've been doing over and over again. You just need to keep in mind the minus sign or positive. That's the only new thing here. Same thing here, except this time they tell us the direct quadrant. They're like, okay, well, sine is positive, but it's in quadrant 2. In quadrant 2, is x positive or negative? Quadrant 2 is over here. X is negative, right? Yeah. That's all you got to do. Once you know the signs, when you start solving these pieces, and make sure whatever has a cosine or an x, you make sure you check that sign is a negative. Okay. Okay. Let's see here. Let's go ahead and do one of these, I guess. Let's do 8 in more detail, since we started it already anyway. All right. So they gave us this information. They said, find the 6 trig functions. I'm going to shorten it up. given that cosine is equal to 12 over 13 and tangent theta is less than 0. All this information tells us we are in quadrant 4, right? We then solve for the triangle. So I'm going to do it really quick since we already did it. Plug in everything. We found b to be b squared is equal to 13 squared minus 12 squared, which means that b, square root both sides, plus or minus square root both sides, 169 minus 144, which gave us plus or minus 5. Right? That's all the stuff we didn't really show. And we're choosing minus because of the quadrant. I think I messed that up. Let me draw this again. Keep doing that. It's adjacent. Cosine is adjacent. Sorry about that. Okay. That's what we wrote on the screen earlier. We chose minus because it's quadrant 4. So the 6 trig functions will be, so sine is negative because y is negative. Tangent, they told us was negative, so negative. Opposite over adjacent. And that's because of the minus 5, but also because they told us. Secant, we reciprocal of cosine. Cosecant, reciprocal of sine. Cotangent, reciprocal of tangent. Okay, so there's our 6 functions. And that's what they had on the screen as well. Any questions on the work or the idea or dealing with the signs, the positive and negative sign? Okay, you guys cool on example 2 then. All right, so let me show you that's problem 8. Let me just really quick go over 9 and 10 in just a second. Okay, you guys cool if I switch over here and turn the page? All right. I'll do that in just a second then. Check out number 9. They have a decimal. So how did they get a bunch of fractions? It's kind of almost like a little trick question there. Do you see what they did? Right over here, we had a fraction, and we were able to build a triangle super easy. Here we don't have a fraction. So what is opposite and hypotenuse, all that garbage? So what would you do if you saw this? Yeah, just convert it to a fraction if we could, right? What is 0.8 as a fraction? It's technically what? 8/10, right? It's in the tenths place. So that means it's in 8/10, which reduces to 4/5. So just change it to fraction on your calculator, or you can reason through it yourself as well, because I'm pretty sure you all know what 8/10 are. And if not, just plug in 0.8, convert to fraction, 4/5. Once you have the fraction, do the exact same thing we did in number 8. Okay. They told you the quadrant, so it'll be a little easier than number 8 because this was a more of a hint, and this is a direct answer location. This one similar to number 8. I'll let you do those. Okay, then move on to reference angles. Reference angle is basically the distance from the x-axis. Okay, that's all you need to know. When they ask you what is the reference angle of something, they're telling you how far is that angle from the x-axis. Let me see if I can find the book so I can show. They have some nice pictures. Which book? This book. Forgot to put 2 books in there. This is the one. 6.3. Reference angles. All right. We're not going to watch the video. You can do that on your own. So as you can see, right, you just find out where the angle stopped, and then you measure. How far is it here? That's the reference. That's all it is. Okay. So if the angle stops there, right, let's say theta goes from here all the way to here, then what's that little distance to the x-axis? That's the reference. Okay. If it goes all the way around and stops right there, again, what is the distance to the x-axis? That is your reference. Does that make sense? So the reference angle of 300, what is that going to be? Right, clear that. Right. So you look at where 300 landed. Actually, you could probably look at our circle. It might be easier. Come back to that. 300 is right here, right? So 300 degrees means I started at 0 and I went all the way around and stopped here. That's what 300 degrees means. So how much more, what is the distance from here to here? Right, this is 300. What is this? Yeah, it's going to be 60, right? Because 360 is a full circle. And if you always start here, and I stop right before the full circle, of course, it's going to be 60. So the reference angle for 300 is 60 degrees, because that's the distance from here to here. Does that make sense? So let's go back to that book example. So that's pretty much what they did. They subtracted 300, whatever, but all you have to do is look at where you are and figure out how far are you. Okay. So this one's a lot easier because it's one of the known angles. Now 2.3 doesn't have a degree symbol. So that's a radian. So right here, what they do is say, okay, well, where exactly is 2.3? So you kind of have to figure out where 2.3 lands on. Also, you can think of it this way. So because 2.3 lands between pi over 2 and pi, meaning it's less than pi, right? We know that that would tell you that you are in quadrant 2, right? So this is a trick that you can do in case you can't figure out where the heck 2.3 is at. This is what you can do here. Remember that pi is 3.14. Remember that half of pi is 1.57. And if you look at your circle, right, pi over 2 is right here. Pi is right there. So if I'm between 3.14 and 1.57, obviously I'm in here, right? Does that make sense? So you just figure out what is this as a decimal? What is this as a decimal? Look at the question that they gave you. They gave us 2.3 radians. That's why they did this. So I say, okay, well, I know where that's at. That's 90 degrees up top. This is pi. This is the 180's location. So I know that it is in quadrant 2. So if it's in quadrant 2, just subtract from pi and you'll get that distance here. So you land right there and you want to know how much further is it to the x-axis. Okay. So knowing what quadrant you're in will help you calculate the reference. If it's one of the easy angles, you can just look at the circle and not worry about it. If it's in radians, it can be a little more annoying, as you can see. Okay. Any questions about this idea? Again, all it means is distance to the x-axis. You just got to figure out where the heck you are and then measure that or subtract from what you do know. Okay. Look at C. C is a negative angle. So C technically goes in the negative direction, 135, right? So let's go ahead and look at this, our actual unit circle, so it's a little easier to follow. Positive 135 is right here, right? So that's this distance right here, all the way around. The negative 135 would be here, right? All the way over here. So what is the distance to the x-axis from here to here? How far is that? I mean, we know from here to here is 45, right? So isn't this just 45? We know an entire little slice of pie here is 90 degrees. Half a circle we know is 180. Full circle is 360. And those are things that we already know, so don't forget. So this distance right here is 45, right? So is that clear or no? let me know. So you see that the question is not difficult. It's just you just have to figure out where the heck you are, right? So that's what reference means. Let's go back to the homework. Ready? So they ask you, what is the reference angle of negative 200? Well, where does negative 200 land on? We know it's going in the negative direction, right? So it has to be going this way. Or actually, their theta prime is the reference. Theta is the normal angle. So this has to be going this direction or this direction for theta. Can't be this because these are positive angles, right? So if you look at your circle, let's try to figure out where the heck negative 200 is. We know 210's right there, positive, right? So it's somewhere in here, 200. So negative 200 would be, let's see here. Right here. Okay. You guys agree with that logic? Negative 200. Oops, actually. A second. 180. Negative 180. Right here. My bad. Yeah. Okay. So it's going to be quadrant 2. So how far is it from here to here would be the question. So an easy way to do this, which is say, you know what, I don't want to deal with the negative. Negatives are weird. So don't forget to add the question negative 200. I'm going to switch over to calculator. Now, negative 200, if we add 360, you agree that we'll end up at the positive version, right? We will end up at a coterminal angle. So we don't have to deal with this nonsense. So now I can just think in positive terms and not confuse myself. So we can just look at 160. Okay, so how far is 160 from the x-axis, right? 160, as we said, is around here somewhere, right? Negative 200. How far is 160 to 180? The x-axis. Right, is it making sense? And so the question is going to be 20 degrees, our answer. And visually, we know it's over here. You see how they're figuring out this picture, right? They're going in the negative direction. They're landing there. So this is the same as 160, we said, right? Yeah. So theta negative 200 is coterminal, meaning it's the same angle as 160, right? So we can look at that one instead. But the reference, which they label as theta prime, is going to be 20 degrees. Okay. Any questions on reference? Do you understand what is a reference angle? The definition, right? It's just that distance. Finding it just depends where you're landing, okay? If you're landing on quadrant 1, that's the easiest one. Just write down the same answer, right? Negatives, you might be easier to adjust to a positive, just like I did. This was easier to deal with, right? 160 was a lot easier than negative 200 to visualize. So you can always do that if you want to. Alrighty. Here they just want you to plug this into your calculator so just use the coterminal angle or just plug that in directly. All right, negative 120 plus 360. That's going to be what? 240. So you can just plug in 240 inside sine, cosine, tangent on your machine, and you'll have these answers. Or look at your unit circle at 240. 240 is right here. So sine and cosine are both negative. Just plug those in until your answers here. That's it. And then we said tangent is y divided by x. That's how they got this. Sine over cosine is tangent. All right. Okay. Any questions on reference angles or coterminal angles or correcting for positive or negative angles? See how all that is coterminal angles, right? Using the positive version. All these are just calculator problems, so they shouldn't be too bad at all. This last one, I'll just delete that. It's just a weird word problem. But yeah, that's pretty much it for 6.3. Any questions on 6.3? You can see how it's very similar to 6.1, right? Or 6.2. Just still a few extra steps. Six 4 and 6.5 are just graphs. Again, I'm not going to make you do this by hand. I want you to just use your online grapher or graphing calculator. So let's go through real quick. So the main thing I want you to know, let me write it down on the paper. The main thing I want you to know is what they look like. Do you know what the graphs of sine and cosine look like? We'll graph them in a minute. The other thing will be, can you find the amplitude and period if I give you a function? So the amplitude, so the amplitude of y equal a sine x and y equal a cosine x represents half the distance between the max and minimum values of the function. The max and minimum values of the functions. Amplitude will be equal to the absolute value of A that is in front of the sine and cosine. So whatever number is in front of sine and cosine, take the absolute value, and that's your amplitude. That's it. Period. Let B be a positive real number the period of y equal to, oh, because I'm not using the b, but a sine omega x plus b and y equal to a cosine omega x plus b is the following. So this is the period. So that's going to equal to 2 pi divided by the omega, or w, whatever. This will be the same for secant and cosecant. Okay. That's all you really need to know. Now I'm going to show you the graphs in just a second. But before we do the example, I want to show you the graphs. So Desmos is is the graph I'm going to be using the entire semester, and you're welcome to use it too. Sine is 0 and 0, 1 at pi over 2, 0 at pi, negative 1 at 3 pi over 2, and 0 at 2 pi. So if you look at your unit circle, all the sine values correspond appropriately. Same stuff on the circle right here for the y values, right? Now, so that's what sine looks like. And cosine is very similar. If you notice, the only difference is that it's kind of shifted a little bit. So cosine is 1 at 0, sine is 0 at 0. And then they kind of are almost exactly the same. They're just kind of just off, shifted a bit. Okay, so you can technically shift them and then make them equal, but anyway. Let's focus on sine for now. Now, if we change the amplitude, we said that that's the number in front of the function. Notice how if I put a 2, it doubles the height. So that distance we were talking about, that's what amplitude is. If I were to quadruple it, well, obviously, there it is, right? So that's all the amplitude does. So if I ask you, what is the amplitude of the purple one? You would say 4, right? So all you gotta do is give me that number. Now, if it was a negative, it would still be the same answer because it's absolute value, right? Let me turn off these for now. There's the original, there's a negative 4. So we've talked about many times. If there's a minus in front, it flips it over, right? Like with parabolas and all that stuff, that's still the same here. So it flips it over, but the amplitude is still 4. So the answer for amplitude is still 4 here. And for this one. Okay, they're just flipped over. That's it. Okay, any questions on how to find amplitude? So if you go to this question, right? Number 5, they ask you, what is the amplitude of this problem? It's just that number, 6. Nothing crazy. Does that make sense? All right, so let's go ahead and do that on paper. We'll do a couple. As you can see, it's pretty much the main idea here. Find period and amplitude, find period and amplitude. This is more conceptual questions about functions from college algebra. So I'll let you read those. The bottom questions, maybe some of these hard ones. All right. Example one will be that same problem we talked about. Find the period and amplitude of y equals 2 6 sine of 3x. Right, so amplitude is equal to the absolute value of a, which is the absolute value of 6, obviously 6. Period, we said it's going to be whatever is on the x, right, divided into 2 pi. So you do 2 pi divided by omega, which is going to be 2 pi divided by 3. Right. Okay. So there is my period. There is my amplitude. Nothing too crazy, right? Now, I guess we should talk about the amplitude a bit. So, I'm sorry, the period. So if we double our omega there, notice how it's basically finishing twice as fast. Okay. It is cycling twice as fast. That's what this 2 is doing. And in essence, if it's twice as fast, then that means that the period has shrank by a factor of 2. So the original sign went from 0 all the way until 2 pi before it started repeating itself. So the original period is 2 pi. Okay. Look at the black one. It repeats itself at pi now instead. So it's half the distance because it's 2 times as fast. Does that make sense? How this 2 changes the period. So if we were to triple that, then it should be 3 times as shorter because it's 3 times faster. So it'll be 0 to, where does it repeat itself? Right here. 2 pi thirds. So instead of going from 0 to 2 pi, it starts over and ends at 2 pi thirds. Where the original goes all the way to 2 pi. So it's 3 times shorter. Okay, so that's what a period does and what's a period means. Just what's the interval for it to begin to start over, to repeat itself. So 0 to 2 pi is the period for sine and cosine. Okay. That's all I really want you to know is what do they look like? Sine and cosine. Tangent looks like this because it has division by 0. So asymptotes appear at every multiple of pi over 2, every odd multiple here. Okay. All these questions down here are reviewing your ideas of functions, graphs, and they do talk about the same thing we just talked about. What's the relationship? If I double this, if I put a minus, what happens? We know that it flips over, that type of stuff. So all these things you already know. I'm not going to really test you on these ideas about shifting, horizontal, how to graph, because you're going to have a graphing calculator or Desmos. So all I want is, can you find the amplitude? Can you find the period? Can you graph one of these functions? And we can use your calculator at that point. So I'm not going to waste my time or your time forcing you to do this by hand. Okay, so that's one place we can save some time. All right, that's it for 6.4. 6.5 is the same thing, except we talk about the other functions, the tangent, secant, and cosecant. Any questions about the graphs themselves? Okay. Let's look at the homework. Oh, just let me write down the notes really quick. For 6.5, all I want you to do is, can you find the amplitude or the period? But let's actually, one second. Let's look at the homework really quick. So you can see number 8, they want you to graph tangent x over 2. So all I want you to do is come over here. Which graph is it? Well, not A or B, that's for sure. Could be C or D. It's going this direction. So not this direction. Has to be C, right? So all I want you to do is just graph it on your calculator or on Desmos. Same thing here, just graph it. In your exam, if it's a graphing question, I am not going to require any work. Just pick the question or draw the graph. That's it. Same thing there. No big deal. Let me delete this question. It's fine. So this would be 6.5 should be very easy and short. You're just going to keep punching them into your grapher and picking the correct option. That's it. There's no real notes for 6.5. Okay. Just read. I do want you to read up on what is the range and domain of these functions. Just I think it also might be on that PDF I sent you. That's about it, though. Okay. So we got about 30 minutes. When you start doing some homework, if you have any questions or anything you're struggling with, I think now is the time. If you want to take a 5-minute break, feel free. Don't waste the time. Please ask some questions.